When we calculated the confidence intervals in the first formula, we used something that we call the standard error of the mean, which is the standard deviation for the population divided by the square root of n being the sample size. The normal distribution you see on the screen is full of boxes, and those are all of the samples for a given sample size n. Let's say n equals 12. This distribution is known as the distribution of sample means, often called also the sampling distribution. I'm going to give you some of the theory here, but I'm going to discuss the theory with you in detail on November 3. But I just wanted to give you some kind of insight to help you get used to using the standard error of the mean, because we're going to use it also to calculate a z-score for hypothesis testing. The mean for this population of sample means is the population mean, but it is called the expected value of the mean because we don't really know it. I've included some information on this slide about the distribution of sample means. The second bullet point is very important because for statistical purposes, a large sample equals n equals 30. Again, the standard error of the mean is calculated simply by taking the population standard deviation and dividing it by the square root of n. The symbol for that standard error of the mean is lowercase sigma subscript capital M. What's the difference between the standard deviation and the standard error of the mean? The standard deviation measures the distance between a score and the population mean. The standard error of the mean, on the other hand, measures the distance between a sample mean and the population mean. So from here on out, we're going to use the standard error of the mean to help calculate the z value. Z is going to still equal sample mean minus population mean, but it's going to be divided by the standard error of the mean. Here's a little 10-point extra credit problem. Calculate the confidence interval. Send me the answers. You got to get all of them correct. There's one other concept I want you to think about, at least for now, and I'll explain more on November 3. It's called the law of large numbers. The larger the sample size n, the more probable it is that the sample mean, capital M, is close to the population mean. In other words, the larger the sample size, the better the sample mean is an estimate of the population mean. Again, we'll talk about that more on November 3. For the z-score and standard error of the mean exercise, I've simply changed the z-value calculation a little bit, that we're now using the standard error of the mean. I've told you what the expected value of the mean is and what the standard error of the mean is. Now you tell me. I've also got notes and PowerPoint in the module tool folders, so if you have any questions, just let me know. But you've done this before, so don't panic. Later.